A pleasant greetings to all. In this video, I am going to explain some of the MCQs in basic electric circuit. The question number 1. In a series RLC high Q circuit, the current peaks at a frequency. In a series RLC circuit, the condition for resonance is XL equal to XC. When XL equal to XC, Z equal to R. Impedance is minimum so that the current should be maximum. At the time of resonant frequency, the current should be maximum in a series RLC circuit. FR, here the frequency. This is the lower cutoff and this is upper cutoff frequency. In the y-axis, Z and impedance as well as I. Impedance is less but the current is maximum. Answer for this one is equal to the resonant frequency. Next problem. Two-port network are connected in cascade. The parameters of the network are obtained by multiplying the individual A, B, C, D matrix. So see, connected in cascade. A dash, B dash, C dash and D dash, that is multiplied with A double dash, then B double dash, C double dash and D double dash. If we multiply both together, we get the ABCD parameter matrix. So, option D is the correct answer. Next problem. The pole zero pattern of a Saturn filter is shown in the figure below. The filter must be of the following types. For this, first we are going to find out the transfer function H of S. See here how to write. This is poles. Here zeros, these are zeros, and this one is poles. Always zeros are in the numerator and poles in the denominator. K is the gain. So S minus 1 minus J, S minus 1 plus J, the S in the S minus 1. So S minus 1 divided by S plus 1, here in the poles, S plus 1 plus J, S plus 1 minus J in the S plus 1. Okay, is equal into S minus 1 the whole square plus 1 into S minus 1. S plus 1 the whole square plus 1 into S plus 1. So here no need to consider this imaginary term. You have to consider the real term only. In a real term, you have to take an angle tan inverse B by A. Here the tan inverse B by A. So tan inverse minus 1 and tan inverse plus 1. So both are same and we will get the value 1. Okay, 1 should be a constant. So this filter is a all pass filter. Next problem. The necessary and sufficient condition for a rational function T of S be a driving point impedance of an RC network is that all poles and zeros should be symbol and lie on the negative axis in the x-plane. That is the correct answer. Next problem. For a two-port network to be reciprocal, if the Z parameter is reciprocal, Z12 equal to Z21. Here this should be reciprocal, means H12 equal to minus H21. This one is correct answer. Here also, if it should be reciprocal, means AB minus BC equal to 1. So the answer B is the correct answer. Next, for the compensated attenuator of figure, the impulse response under the condition R1C1 equal to R2C2. What is the impulse response? H of S is the Laplace transformation of output to the Laplace transformation of input. So first write V2 of S, that is R2 parallel 1 by C2. Here what is this? R2 parallel 1 by C2 plus R1 parallel 1 by C1. And how to find this? 1 by C2 is the Laplace transformation. R2 into 1 by C2 is divided by R2 plus 1 by C2 is. How to write this? R2 divided by C2s, R2 C2s plus 1 divided by C2s. Both are get cancelled, and finally the value obtained is R2 divided by R2 C2s plus 1. Now I am going to substitute this in V2 of S divided by V1 of S. R2 divided by R2 C2s plus 1, R2 divided by R2 C2s plus 1 plus R1 divided by R2 C2s plus 1. So it is the condition here. The condition is R2 C2 equal to R1 C1. Here in this problem, you have to substitute R2 instead of R2 C2, you have to substitute R1 C1. Here also R1 C1. Now see, both the denominators are same. Have to cut this. Finally we get R2 by R1 plus R2 into what is the Laplace transformation of inverse transformation of 1, that is del of t. This is the Laplace transformation, this is inverse Laplace transformation. That's all. The answer is B. And next problem, on the four networks N1, N2, N3, N4 of figure, the network having identical driving point impedance are first of all N1. So in the N1, 2s plus 1, here this is 2s plus 1, and here 2 plus 1 by s, that is in parallel with 1 by s. Now I have to reduce this 2s plus 1 in the, here I have to reduce this one first, 1 by s equal to 2s plus 1 by s in the 2s plus 1 by s divided by 2s plus 1 plus 2s plus 1 divided by s. So 2s plus 1 into 2s plus 1 divided by s, the whole divided by 2s square plus s plus 2s plus 1. Now I have to reduce this. I'll get the answer 2s plus 1 into 2s plus 1. Both the s are get cancelled, divided by 2s square plus 3s plus 1. If we divide this, we get 2s plus 1 into s plus 1. Okay, now both the 2s plus 1 get cancelled, and finally we get 2s plus 1 divided by s plus 1. Okay, so what is the first one? The first one is 2s plus 1 plus s plus 1, that is in parallel with 1 by s. This is for n1. What is n2? 2s plus 1 parallel with 2 plus 1 by s. Okay, see, both are completely different. And for this one, how to find this? For this one, 2s plus 1 parallel 1 by s. These three are not same. Now I am going to try for n3. So for n3, here in the 1 plus, so first of all the parallel combination. So 1 plus s plus s divided by 1 into s divided by 1 plus s plus 1. So s plus 1 plus s divided by 1 plus s. So 2s plus 1 divided by 1 plus s. That is in parallel with n3, parallel with 1 by s. Now see, look at this one, that is n3, and look at this n1, both are same. The answer is n1 and n3, both are same. It is solution. This is the solution. C is the correct answer. And next problem. A DC network in figure has a voltage source V, a current source I, and several resistors. A particular resistor R dissipates the power of 4 watt when V alone is active. The same resistor R dissipates the power of 9 watts when I alone active. Power dissipated by R when both the sources are active will be. So this is superposition theorem. So first V alone active and the power is 4. V alone active and power is 4. What is the formula? P is equal to I square R. What is the current I? I is equal to P by R. Okay. So I is equal to 4 divided by R square root, that is 2 by R. This is for the first one. For the second case, the same resistor R dissipates the power of 9 watts when I alone is active. So P is equal to 9. So 9 equal to I square into R. What is I? Square root of 9 by R. I is equal to 3 by square root of R. Okay, next, if both are active, so both the sources are active. So both the sources are active means summation of 2 divided by square root of R. Both the sources active, so I square into R, the total power equal to power dissipated by R. I is equal to, the first I is 2 by root R. Second I is 3 by root R. The whole square into R. So 5 by root R, the whole square into R. So 25 by R into R. So that is the power. So 25 watt is the correct answer. The network consists of linear resistors and ideal voltage sources. If values of all the resistors are doubled, then the voltage across each resistor is. Here I am considered the series circuit that has 2 resistors and 1 voltage source. So the question is, If the value of all the resistors are double, then the voltage across each resistor. For this case, R1, R2, V. I am going to find out voltage across R1. I have to take that is VR1. So VR1 is equal to total voltage into the same resistance divided by the total resistance. So that is VR1. Now I am going to find out if all the resistance are double, is there any change? So the first resistance is double, 2R1 plus 2R2. I have to take 2 outside, 2R1 divided by 2 into R1 plus R2. 2 get cancelled, but the equation is not changed. Both are same. So answer is not changed. Next I am going to explain the problem number 10. The two electrical subnetworks N1 and N2 are connected through 3 resistors as shown in figure. The voltage across 5 ohm resistor and 1 ohm resistors are given to be 10 volt and 5 volt respectively. Then voltage across 15 ohm resistor. So first of all I am going to find out what is the current flowing through. I0 plus I1 plus I2 equal to 0. Take this is I0, this is the current I1, this is I2. I0 plus I1 plus I2 equal to 0. I15. So I0 equal to 5 by 1 plus I15 plus I2 equal to 10 by 5 equal to 0. So I15 equal to minus 5 minus 2, that is minus 7. So what is the voltage? Voltage V15 is 15 into 7, 105. So the answer is minus 105 is the correct answer. Thank you. Have a nice day.